Okay, second module here you got to study two chapters. One is about things in IoT. Okay, in this chapter we will be discussing about sensors. What is sensors? What are its different types? And based on what factors different types of sensors are present. And the same goes with actuators. What are actuators? A few examples under this, and what actually the smart objects are, and also the sensor networks that is used to connect the sensors to the network. Okay, that we are going to study in the first chapter. And in the second chapter, as I said, we'll be discussing connecting these smart objects, right? So this, with respect to this, we are going to discuss communications criteria and IoT access technology. Let's start with the first chapter, which deals with smart objects. So what is smart object? As I said, it is things in IoT. What does it mean? So Internet of Things, which is nothing but a collection of sensors, right? Which sends the data and transmitted over the network, and it will be stored in the cloud, and where the processing of data will be done, right? So, and based on this processing, the required decisions will be taken and implemented, right? So this is the overview of how the IoT works, right? So let's start with sensors. What actually sensors are? As you know, sensors sense, or it measures the physical quantity, right? So for example, say I deploy a temperature sensors in a room in my home. So what does that it does? It senses the temperature of current temperature of the room, right? So that is measuring physical quantity. So once it measures, what it does, it converts that readings into digital representation, right? It is converted into digital representation because it has to be transmitted over the network, and it should be given for the processing, right? So if the temperature is more, if there is a fire at my home, then what is it? It sends, it crosses the threshold temperature readings, right? So it says that there is more temperature, so the required action has to be taken, right? So that's why this measurement data is converted into digital representation. Okay, and this digital representation is passed on to another device for the transformation. Then it is consumed by the intelligent devices or humans. So this is read by the devices or humans to take the respective action or to make proper decision. Okay, this is all about sensor definition. So see, sensors falls into different categories. Okay, so those categories are active, it can be active or passive. Okay, invasive or non-invasive, right? And contact or no contact, and then absolute or relative, area of application, how sensors measure, and what sensor measure. So these are the different categories that is followed for the sensor. Let's see one by one. Okay, the first one is active or passive. Say we say the sensors are active when they produce any energy output. Okay, and it require an external power supply. So then that we call it as sensors are falls into active category. And you can see sensors are passive when they simply receive energy and require no external power supply. So such sensors falls into passive category. Okay, so next type category is invasive or non-invasive. See, sensors is a part of environment. It is measuring or external to it is called as non-invasive. I'll repeat. So invasive is one where sensor is the part of the environment that it is measuring, or external to it, that then we call it as non-invasive. Let's see few example here. Uh, See, invasive, here I have considered an example where we inject a sensor under the skin. Okay, so you can see here, this is an example where the sensor are injected to the hand of this person, which what it does here, it reads the glucose meter, glucose level, and it transfer to the control system. Okay, that is an example. Fine. So next category is contact or no contact. So this contact is that physical contact with what they are measuring. Okay. So let's say temperature. So this temperature, this is an example for temperature sensor which senses. This will be in the physical contact of the surrounding. Okay. So such sensors falls under contact sensors. No contact is what? This example. See, I need to measure the water level of this tank. So, what does it do? A sensor is attached to this tank, and it checks the level of water, and the readings will be passed onto the device where it can be controlled or checked. So, this is one example for no contact sensors. Okay, next type is absolute or relative. So absolute are one whether they measure on an absolute scale. Okay, that is about absolute, and the relative is one based on the difference with a fixed or a variable reference value. So if any sensors falls under absolute scale, then that we call it as absolute falls under absolute category, and if there is a sensor which falls under fixed or a variable reference value, then we call that falls under relative category. Okay, and the next category is area of application. See, all the sensors can't be used in all the fields, right? Say the temperature sensors, you can use it to check the temperature of a room or something like that. If there is a sensor which checks the moisture of a soil, then that should be used to check the soil moisture. The deployment of the sensor is different, right? Temperature sensor deployment is at different field, right? So based on this, the category is also decided. That is area of application. Next category is how sensors measure. So here physical mechanism used to measure sensory input. Okay, then that we call that, the sensors, then we call it falls under this. Like for example, see, if you want to check electrochemical or electric or fluid mechanics, this is a physical phenomena or a mechanism is involved, right? So with respect to that mechanism, sensors are deployed, right? So that comes under this category. And next is what sensors measure, right? So here this based on their application or what physical variables they measure. So that comes under this, what sensors measure. So altogether you have categories like active or passive, invasive or non-invasive, right? And contact or no contact. Next, absolute or relative, area of application, how sensors measure and what sensors measure. Okay, these are the different categories of sensors. And here few sensor types are given, which is listed here. Sensor types based on the position the sensors are used. The examples also listed here. You can go through this table. For position, you can see proximity sensor, so which we use it in cell phone as well, right? Occupancy and motion, like radar. Velocity and acceleration, accelerometer or gyroscope, so which we use it in cell phone. Uh, with respect to force, that is force gauge, tactile sensor or touch sensor. So many types are given here. You can go through it. Force with respect to pressure, flow, acoustic, humidity, light, radiation, temperature, chemical, biosensors. So these are the different types of sensors that are used in the market or used in different application or in the different fields. Okay. So they can ask you to list out few sensor types. In that case, based on the marks, you have to write the types and what type, description of the sensor type and examples for that. Okay, you need not to write all the sensors listed here, but based on the marks, you have to write the types. Okay, and next, this is one example which is used in the agriculture. Okay, so as you know, IoT application varies in different fields, right? So here, see, the sensor is used in the smart farming, right? So, and these sensors are also biodegradable sensors. What does it mean? Even though it decomposes here, it will not harm the soil fertility. Okay, so here, actually, when I say smart farming, many sensors are deployed in the soil, right? It may be to measure the soil quality or pH level of the soil, salinity, toxic level, and also moisturizer, right? So these are all helps. I mean, when these sensors are deployed in the soil, it will read the respective physical quantity in real time, right? And based on that, the farmer can decide what action need to be taken. See, if the moisturizer level is less, then what he can plan for irrigation, right? So if there is a toxicity level, then he can take the respective action, right? And also he can check the fertility of the soil and all that, right? So in that case, he can take the respective action so that he can increase the crop rate, right? So here, so this is one such example. I mean to say, NDSU, right? This is developed at the North Dakota State University. Okay, and this is planted directly in the soil, and it can be left in the soil as is said, because it is biodegradable. Okay, even this decomposes, it will not harm the soil quality. See, this is one such application. Okay, so another example is sensors which are used in smartphone. And you know, in cell phone, we use what more than I mean, many sensors in our smartphone, isn't it? So here, as you know, day by day, the usage of smartphone is increasing because of the advancement in the technology, right? And each and every year, the smartphone, billions of smartphone are into the market, right? And the count is also increasing every year, right? So here in smartphone, there may be hundreds of sensors deployed. While manufacturing the sensor, this is one such example considered here, where for the near field communication, sensor is used, proximity sensor, then accelerator, magnetometer, humidity sensor, gyroscope, moisturizer sensor, microphone. So there are many sensors are deployed in the smartphone. That's why we are more, I mean, we are more, actually, I can say, addicted to the cell phone, because every details you will get on your tip of the finger, right? So this is one example for that. And this graph shows, as you can see here, this shows growth and the prediction in the number of sensors. So usage of sensors per year is represented here. In 2007, the count, it's around 1 crore, right? So as you can see here, every year it is growing, right? It is growing like anything, right? So the usage of, I mean, the sensors usage is increasing in all the fields of the application in the market. So that is what depicted in this graph. And and you can check in the car as well. When I see car, you know, many sensors are deployed, right? Nowadays, whatever the car or comes into market, many sensors are deployed, right? That's why uh, the sale of cars is increasing day by day, which gives us a comfort life, isn't it? So that is another example under sensors. And next is actuators. So what are actuators actually? See, actually, sensors, what does it do? It sends the data, right? And it converts the physical measurement into digital representation, right? So, this digital representation, once the digital representation is received at the processing end, the certain decision has to make, right? So as I said, if there is a fire at my place, if I have installed deployed sensors, then it will sense the what fire. That means since there is increase in the temperature in the room, it passes that data to the what control uh, system, right? So once it received the data at the control system, what control system has to take? It has to take the respective measure. Maybe what it has to start. I mean, water sprinkling the water on the fire, right? So that operating a device which start sprinkling the water on the fire is nothing but a actuator. Okay, you can see here the sensors which are deployed in the environment, which senses, which measures the physical data and convert it into digital representation, right? So here, once it is read at the control system, this control system acts on based on this data. So that we call it as actuators. Okay. So this is a small representation how sensors and actuators work together. Okay, so that is been given here. So sensor actuator receives the control signal that triggers a physical effect, usually some type of motion or force, and so on. As I said, water will be sprinkled on the fire, right? So that is what the action taken on the control signal. Okay, so that is introduction about the actuators. And let's consider this example where you can see these are all the what sensory organs of a human, right? Eye, ear, nose, tongue, hand, right? So once all this organ senses, what does it do? It converts this sensory information into electrical pulses, right, through the nervous system, and sends it to brain for the processing, right? So based on the processing, the action will be taken. Based on that, our hands and legs will move, right? In the same way, this is compared with the sensors and the actuators. Sensors senses and passes the sensory information to the processing unit. Say CPU is used here, and this will tell what action need to be taken for this sensed data. So that is actuator. Okay, so you can see here IoT sensors are devices that sense and measure the physical world and signal their measurements as an electrical signal sent to some type of microprocessor or microcontroller for additional processing. Okay, after the processing is done, the required action will be taken by the actuators. Okay, this is the working of sensors and actuator altogether. Fine. So next, the actuators are classified into different types. That is, one type is type of motion. That is actuators. As I said, actuators does some kind of action, right? So this actuator classified based on the type of motion they produce. For example, if there may be a linear, rotatory, or one or two or three axis. That is one type. Next, with respect to power, here it is based on their power output. If it follows high power or low power or micro power. Okay, that is second type. And third one is binary or continuous. See here, number of continuous is what? Continuous is, if you consider analog clock, where you the minute hand, hour hand, and seconds hand, it continuously shows the time, right? So that is continuous, right? So one example for that continuous is stepper motor. Another, let's consider the binary, which discrete values are given, right? Either 0 or 1. Example for such type is relay in the automatic control application. So this is a stepper motor which has 6 poles. This router will require 24 pulses of electricity to move 24 steps to make one complete revolution. This is an additional example I've considered. That's it. Okay. For binary, it is automatic control application where 2 states will be given. That is off or on. Stepper motor, it continuously rotates, right? That is example for continuous type. Next is area of application. As I said, with respect to sensor, the same goes for this as well. The actuators are specific for certain industry. Next, type of energy. See, the actuators are also classified based on their energy type. Okay, and different types of actuators are enlisted here, like mechanical actuators, electrical actuators, electromechanical actuators. See, the different types are listed here, and few examples are also given for the same. Okay, you can just go through it. For mechanical actuators, you can say levo. Electrical actuators, bipolar, transistor, and diode. Electromechanical actuators, AC motor, DC motor, step motor. Electromagnetic, linear solenoid, and the say examples are given. You just go through with that. Okay. So after studying sensors and the actuators, next topic is micro electromechanical systems. In short, you can call it as MEMS. Okay. So MEMS is a nowadays trending topic for the research. Many research is going on this topic. Okay, so now why it is so? I mean, so much. I mean, why there is a boom for this MEMS in the market? Let's see what makes this MEMS most popular in the research area. Actually, this means is micro machines. Micro machines means what? Very tiny machine, right? Which may comes in nanometer or something like that. So the machine which is a very small in size. Okay. So this micro machine can integrate, combine electric and mechanical elements such as sensors and actuators on a very small scale. So, okay, so this is what it is, a machine on which you can integrate sensors and actuators. So that is called as micro electromechanical system. See here, this is an image I have taken where the sensors and actuators are deployed on this machine. Okay, so this how this sensors and actuators are integrated on the micro machine with the help of micro fabrication technique. Okay, and because of the tiny size of this machine, and it is very low cost and ability to mass production, makes MEMS an attractive option for a huge number of IoT application. Since the size of the MEM is very less, okay, and the cost is also very less, so that's why this MEMS are used in IoT application. Okay, examples in inkjet printers use micro pump MEMS. Okay, so this is few examples I have listed. Smartphone also MEMS technology used for like accelerometer and gyroscope. What does it mean? See, both sensors and actuators are embossed on the machine. Okay. So next example is like automobiles. where actually first MEMS introduced in automobiles first, like airbag accelerometers. Okay, and this is a picture I've taken from the internet. See, this is the base on which sensors and actuators are embossed here. Okay, so next, these are the components of MEMS, which is not given in the syllabus, but I just listed it out, like microelectronics, microsensors, microactuators, and microstructures. These are the components of MEMS. Actually, for electronic students or for electronics, they study more about this MEMS. Okay, so this is application, like this how it looks when it is used in the smartphone or the tablet or cameras. Okay, so I've just taken that picture, and this is what the image given in your textbook. This is MEM, which is only few hundred micrometers across. The size is very less. How much? Few hundred micrometers, on which the sensors and the actuators and all the required things are embossed on this machine. Okay, so these are the few examples I have considered. Means accelerometer looks like this. Means gyroscope looks like this. Okay, and in car, this is also used, as I said. There is fuel injector, pressure sensor, GPS, for airbag, for microphones, noise cancellation, exhaust gas sensor, corrosion sensors, tire pressure sensor. So all together, this is implemented with the help of MEMS. Okay, automotive applications of micro electromechanical system. In short, you can say. Okay. After studying sensors and the actuators, next thing is smart objects. So what is smart object? Sensors and actuator all together we call it as smart objects. Okay. So let's see a few points about this. So the smart object can contain one or multiple sensors and or actuators depending upon the application. The smart objects may be the collection of sensors or actuators or all together. That we call it as smart objects. Okay. So and this smart object defines four characteristics. The first one is processing element, second one is sensors and or actuators, third one is communication device, and fourth one is power source. So these are the four different characteristics of smart object. Let's discuss one by one. Processing unit, I mean, what are the functions that has been done under this processing unit that we are going to discuss. The first thing is what? It acquires the data and then process it and then analyze it, okay, and then coordinate control signals to any actuators, and the last one is it controlling a variety of function on the smart object, including communication and power systems. So these are the function of this processing unit. The first one is acquiring the data, I mean collecting the data, I mean receiving the data and then processing it, and then analyzing the data received from the sensors and coordinating the control signal with the help of actuators, and then controlling variety of functions of the smart object. It may be communication or power systems. Okay, that is processing unit. So I said processing unit is nothing but a microprocessor or a microcontroller, right? So here few examples I have considered, that is microcontroller, maybe ESP8266, ESP12 microcontroller, or Arduino, or any other microcontrollers are used for the processing. So few micro controllers I have listed here. Okay, and the second characteristic of smart object is sensors and or actuators. So this part I already discussed in the beginning of the class, so I'll not discuss this point now. Next characteristic of a smart object is communication device. Okay, So communication device is what which helps connecting the smart object with another smart object with the help of network, right? That is what this says. The communication unit, which is responsible for connecting a smart object with other smart object and the outside world with the help of network. Okay, see, so sensors or the actuators has to communicate with each other to perform some kind of action in any application, right? So this can be done with the help of communication unit, that is with the help of network. Okay, so this communication can be wired or wireless, right? So wirelessly, many, smart objects are connected because it is uh, uh, many reasons, because of the because of the cost, limited infrastructure availability, and ease of deployment. Okay, so for these reasons, smart objects are connected wirelessly. Okay, so that is about communication device. And the fourth characteristic of smart object is power source. And you know, any sensors or you consider actuators, it needs some kind of power to work, isn't it? So that is what it says. Smart objects have components that need to be powered, right? So here the power consumption happens because of the communication unit that is present in the sensor. See, if you take our cell phone only, if you use Wi-Fi or internet continuously, then obviously your what a battery will drain out, right? So even power source is also one of the concern when it comes to smart object. Okay, so the battery powered or scavenger sources are used as power sources. Okay, so that is about the four characteristics. And this is the whatever the characteristics that I discussed so far is represented in this image. You can see this is sensor and this is actuator, and there is communication device as well, and power source as well. Okay, and this processing unit is also present here. Okay, so this low cost computer which helps in CPU helps in processing, right? When there is processing, then it requires memory, so memory is also present here. And to process you need power source. When you are communicating with other device, you need power source, right? And sensors and actuator is also present on the smart object. So this is the characteristics of a smart object. Do remember, smart object can be a collection of sensors or actuators, or collection of sensors and actuators. Okay, so next topic is trend in smart objects. See, because of many reasons, the smart objects are in trend. Okay, because of the size is decreasing. I mean, the smart object size is reducing day by day. So it has become a small. The size has been reducing. So you can use it anywhere. The second reason is that power consumption is also decreasing. See, due to advancement in the technology, even power consumption is also decreasing. So smart objects are in trend. Next, processing power is increasing. Again, with that what advancement in the technology, this is possible, and communication capabilities are also increasing, and communication is being increasingly standardized. See, many company or the manufacturers are coming up with open standards. That means different sensors of different manufacturers are compatible. If they are compatible with each other, then communication can happen more easily, right? So even that is also improving. That's why the smart objects are in trends now. Okay, those are the reasons. Now, next is last topic of this chapter, that is SANET. SANET is Sensors Actuator Network. Okay, SANET stands for Sensors Actuators Network. So here, uh, this SANET is what? It is a network, okay, of sensors that sense and measure their environment and or actuators that act on their environment. So this is sensors actuator network. I'll repeat. SANET is a network of sensors that sense and measure their environment readings and or actuators that act on their environment. So you can see here SANET coordinated sensing and actuation capabilities. Okay, smart homes are a type of SANET that display coordination between the distributed sensors and the actuators. This is one example for the smart home for sensors actuators network. In short, you can call it as SANET. Okay. So example is smartphone. As a smart home, as I said, we deploy temperature sensors, right? Based on that, this havoc system works. Heating will be taken care, ventilation will be properly maintained if the temperature is more in the room, and air condition is also regulated uh, with the help of SANET. Okay, so that is one example for this. And so when there is one second, yeah, when it crosses the specified threshold temperature, then this triggers an actuator to take action and heat or cool the home as needed. Okay, that is how it works. So advantages of using wireless solution or the wireless network is that first one is greater deployment flexibility. Second one, simpler scaling to a large number of nodes, lower implementation cost, easier long-term maintenance, effortless introduction of new sensors or actuators nodes, and the last one is better equipped to handle dynamic or rapid topology changes. See, these are advantages of using wireless network with respect to SANET. Okay, so a disadvantage is that it is less secure because wireless mode is used, and low transmission speed. Okay, and the last one is impact. The impact will be more by the environment. See, if I see sensors, when I deployed in an environment, okay, it may work for a few environmental condition. It may not work when the environment condition changes. Okay, that is what the last point in the disadvantage says. Okay, and the last part is wireless sensor networks. So what is a wireless sensor network? Obviously it is made up of wirelessly connected smart objects, which is also called as modes. Okay, so this smart objects are connected wirelessly, then we call that is as modes. Okay, and this has limitation because of few factors, that is it has limited processing power, limited memory, lossy communication, limited transmission speeds, and limited power. Okay, because of this, whenever there is wireless sensor networks used, these are the reasons why you can't go to a larger extent. Okay, and another example given here, you can look at this diagram where uh, what nodes are deployed, and all these nodes are what wirelessly connected. Okay, the temperature sensors are deployed, and it sends the data and transmit over the network, which the network used is WSN. Okay, so in WSN there is a function called data aggregation, where temperature readings from a local grouping of temperature sensors are aggregated as an average temperature reading. So what does it do? Here, it all senses, different sensors senses the data and gives it to the data aggregation point where it calculates the average temperature and then pass it on to the network for the further process. Okay, so this data aggregation technique helpful reducing the amount of overall traffic in WSN with a large numbers of deployed smart objects. See, if you take this case in general, what happens here? Each what smart object will sense and pass the data to the processing place, right? So in this case, because of the data aggregation function that is implemented in the WSN, what it does, instead of sending data from each smart object, it will collect it and then it will process, then it will find the average of this, and then one reading for this will be sent to the processing center or the control system, right? So this is an advantage of this WSN, that is wireless sensor network. Okay, and this wireless connected smart objects follow two kinds of communication. One is event driven, another one is periodic. Event driven is transmission of sensitive information is triggered only when a smart object detects a particular event or predetermined threshold. That means, see, event driven, say, there are sensors which are deployed to sense is there an earthquake or any disaster, right? So that is the data is collected only when such calamities or the actions happens, right? So that we call it as event driven. Periodic is what? Say temperature, say I need to find out the temperature of a room at a regular intervals or the periodic intervals, then that comes under periodic communication pattern. Okay, these are the two communication pattern followed in wireless sensor networks if the smart objects are connected wirelessly. Okay, yeah, that's all in this chapter.